Imagine if you want to reboot a device that is located somewhere where you don't have an easy access to that device. So you can disconnect the power. But I was thinking, what if I could use one of those remote control operated outlets to power off my device? I didn't expect it to work without modifications. Here's why. So when I plug this device in, this remote control switch, it starts always in the off position. I can then use the remote control button to turn it on. So like this, it turns on. However, if the power is lost at the site, like this, and gets restored, the device will be off. So I don't want the device to be off. I want it to be only off when I want it to be off. I also do not want the device to be turned off for a long period of time, more than necessary to reboot. So I want to limit that time, how long the device can be staying off. And here's a modification I made to this box. All the additional electronics fits inside the switch. So now when I plug it in, by default, my load will be turned on. So I don't need to push any buttons. The relay is not energized. It's just a straight bypass. Now, if I push a button on the remote, watch this. I push the button. It actually works in reverse, so it turns off the light. However, after 12 seconds, it doesn't matter if I push buttons again. After 12 seconds, it will restore the power to this device. So this is enough time for the device to reboot, and the power gets restored. Now, if I push the button, for example, and I leave it in the on position, after 12 seconds, regardless of what the state of this light is, the device will be powered back on again. So again, I'm not touching anything. 12 seconds passed, the device turns on. And that's exactly how I want it to work. For this project, I used this kit that comes with 2 control outlets and 1 remote. I think the whole cost for this was around $25 or so. It looks pretty nice, pretty solid. So inside we have 2 outlets that are in parallel, so they cannot be switched individually. So the power comes in here, this is the line, goes through the relay, goes back to the outlet. The thick white neutral wire goes to the outlet directly, and the thin black wire is connected to the white, goes back to the board to power everything on the board. On the back we have the rectifier and the power supply chip, 12 volts, that goes to the relay. Then there is another regulator that makes 5 volts, and that is used for the board, to power the board here. There are 5 pins on the board, 2 for power, 1 goes to the relay, and 1 goes to this button here, and the last one goes to this LED, which can be blinking during the programming or be on or off to show what the status of the output is. Unfortunately, the relay here does not have the normally closed contacts, so I'll have to replace it so that my load can be on when the relay is powered off. So I needed a circuit to allow me to prevent the load being in the off position for more than 10 or so seconds. So I'm using the 555 timer for this, and with few components I should be able to fit everything inside this space here. My initial prototype was pretty messy, just a bunch of components connected with a bunch of wires. And instead of relay, I used an LED to indicate that whether it's on or off. So I connected it to 5-volt power supply. So here I'm connecting the power. LED starts with being off, which is good. That's what I want. So this is my input. This is control lead. And when I touch the negative side, nothing happens. But as I touch the positive side, that's what triggers the 555 timer, and the relay, or in my case LED, turns on for about 10 seconds. So it stays on, and the timer will, after expiration, turns it off. I then replace the relay with the one that has normally closed contacts. So this is the one. It's smaller, so it doesn't carry as much current. I cannot power a 15 amp load as before, but in my case, I'm not expecting to power more than a 100 watt load or 1 amp or so. And here I'm testing my new relay wiring. To simplify testing, I added a new neon light between the 2 outlets. So the LED on the left shows when the power to the relay is on, and the neon light shows the power to the outlets. And as you can see, the two are alternating. So when the relay is on, the power to the outlets turns off. And that's exactly what I'm interested in. To make the assembly as small as possible so I can fit it inside the original box, I didn't use any PCB. I just wired the components together and have these 4 leads coming out of them, 2 for the power and 2 for the input and output. I then wrapped it inside the plastic that I took from some recycling so that the assembly is well insulated. I then cut the trace that goes between the output of the circuit board to the input of the transistor that controls the relay. So I cut it so I can insert my delay circuit in there. And here's how the circuit is wired in place. I have 2 wires that are connected to the 5-volt supply and 2 wires that are providing the delay and limiting it to about 10 seconds or so. And here I will put some extra insulation and make sure that no wires are close to the mains. So this is how it looks. The circuit worked just outside of the box, but the moment I put it inside here, it stopped working, or it actually worked, but would get re-triggered at the end of the pulse. So sometimes it would happen that you would wait 12 seconds expire, and then right at the end it gets re-triggered again. And you wait another 12 seconds. So eventually it gets restored to the always on position, which is fine, but that was still annoying. I tried different things. I tried even replacing transistors, added filtering here, added filtering there. What the problem was, and what fixed it, is actually adding this capacitor here. So I increased this capacitor to 0.5 microfarad, and this is a low capacitor, and that's what cuts off the noise. And what I suspect the noise was coming from was from the relay inside here. So when the relay was powered off, there was some kind of pulse that gets generated that gets picked up by this 555. I was able to test the range of the remote control up to 100 meters, or about 300 feet, and it worked fine. So I wasn't able to test longer than that. And it seems pretty reliable, and I'm pretty happy about how it turned out.